sure in 7th grade, if not in 6th grade. An equal sign means the result of the left is equivalent. I want to use a fancier word than equal. Equivalent to the result on the right. And you guys did this with solving equations. We knew they were equal, or when we were solving by substitution, we could swap them out because they were equal. We can compare numbers with exponents as long as they have the same base. Remember, the base is the number that is repeated. Okay, so what is different about these equations and what we have been solving? Where's your variable? In the exponent. Okay, so your variable's in the exponent. So step number 1 is that we have to have the left side and the right side so that they have the same base. And this is going to come back to when you guys did your factor trees when you found those roots of things the other day. Okay, I have 6 raised to a power. Well, I don't know how I can break down 6 besides 2 and 3, right? 216. What I always say is try 6. How many times does 6 go into 216?
Let me ask my calculator.
No, because 6 times 3 is 18, but 36, okay? Now, 36, how many times does 6 go into 36? 6. So really, 216 could be rewritten as what? 6 to the 3rd power. Everybody follow how I did that? Okay? So really, 6 to the x is equal to 6 to the 3rd. All I've done is change 216 to be 6 to the 3rd. Do you have the same base? Here's where the magic occurs. When you have the same base, you drop the base, and you set the exponents equal to each other. X equals 3. Normally at this point, we have to solve for x. The beauty on this problem is it's already solved for x, right? X is 3. Thatcher.
And then you put 3 into the ALG.
Yes, it'll say like x equals, and you would type in 3. Correct. Okay. Go down. 12 raised to the 2x plus 3 equals 144. So things got a little more intense here, but the same situation. We need to have the same base. Can you rewrite 144 with a base of 12? So break down your factor tree. 144 can be broken down as 12 times 12. So really, 12 to the 2x plus 3 equals 12 to the 2nd. Our bases match. We drop the base. We then set 2x plus 3 equal to 2. Now this one we actually have to solve because x isn't by itself. What's my next step? Subtract 3. 2x equals -1. Then I should divide by 2. Help Amber out. Does Miss Hoff ever let you give her decimal answers? No. And Alex, have you ever used Alex, the online math program? Okay, you'll love it, or you'll hate it, but hopefully you'll love it because we use it all the time. Okay, so you would end up writing in as a fraction. You can always double check this. If I plug this back in, guys, I'm about to assign new seats. Zip it. 2 times -1/2 plus 3. What's 2 times -1/2? -1 plus 3 is 2. 12 squared is 144?
Yes. So
just like with every other equation we've solved, when you plug it in, it will still make a true statement. Okay? Have to match the base. We have to match the base. Top right. 25 to the x minus 1 equals 5. What's my exponent on 5? 1. Okay, it's a 1. What do you think? What base do you think I should have here? 5. Okay, so this time a little bit different. We're going to change the base that has the exponent. And really 25 is 5 times 5, yes? So I could replace 25 with 5 squared. Now, I'm only replacing 25 with 5 squared. 5 squared is still raised to the x minus 1. Does everybody follow what just happened there? Okay. This time, our exponent base needs to be adjusted. Okay. Now, I know you're going to say, Ms. Hoff, we have the same base, we can drop them. Not quite yet, because we have a weird parenthesis over here. Laws of exponents from last week. When you raise a power to a power, you multiply. You want to rewrite this like so. 5 with 2 times x minus 1. Is it essential that x minus 1 is in parentheses? Yeah, because you got to distribute that 2 eventually when we get there, right? Now that my parentheses are up in my exponent, I have the same base. I can drop my base. 2 times x minus 1 equals 1. What should I do first? Distribute. I'd end up with 2x minus 2 equals 1. Plus 2. 2x equals 2x equals 3. Divide by 2. X equals 3/2. Now, technically, again, you can check this if we plug it in here. 25 to the 3/2 minus 1. If I'm going to subtract 1 from 3/2, I have to have a common denominator, which would be 2. So really, it'd be 25 to the 3/2 minus 2/2. And 3/2 minus 2/2 is 1/2. Remind me what you learned last week. A 1/2 power is what? The square root, right? It really means the square root of 25. What's the square of 25? 5, which is where you wound up here. Okay. Have to match the base. We have to match the base. Flip it over. Yes, I know I skipped one. Okay, so we get more intense. Left-hand side here. 5 raised to the 3x minus 2 equals 125 to the 2x. What base do you think we should have? 5. So on the left, I don't have to adjust it. I'm going to leave that. 125 is what? Huh? Okay, thank you. So 5 to the 3x minus 2. And then I'm only replacing 125 with 5 to the 3rd. I still have the power of 2x on there. The left-hand side is going to stay. On the right-hand side, when you raise a power to a power, you multiply. Ultimately, this is pushing your parentheses up into your exponent. That's all it's doing. Because now I have the same base and I can drop it. 3x minus 2 equals 3 times 2x. What should I do first? There is no distribution to be done here. Multiply. 3x minus 2 equals 6x minus 3x. Negative 2 equals 3x. Divide by 3. X equals negative 2/3. Questions so far? Okay. Let's go to the right. 9 to the 3x minus 3 equals 6,561. I'm sure you know exactly what that is 9 to what power, right? Let me help you. Watch. Use your factor tree. You want a base of 9. Don't guess and check. Whoops. Rewrite this with a 9 taken out of it. Take 6,561 divided by 9. What do you get? 729. Take 729 divided by 9. What do you get? 81. Take 81 divided by 9. What do you get? 9. So really 6,561 could be rewritten as 9 to the 4th. So 9 to the 3x minus 3 equals 9 to the 4th. What do I do now? Drop my bases. 3x minus 3 equals 4. Add 3. 3x equals 7. Divide by 3. X equals 7 over 3, or 7/3. I will count it wrong. Mixed numbers are useless in algebra. As much as they had you work like 5th grade, 6th grade, even 7th grade writing mixed numbers, they are completely worthless once you hit algebra. Just because the first thing you have to do is change it right back to improper. Okay? All right, how about this guy? What do you want your base to be? 9? Okay. 9 goes into 27 how many times? 3. Can I rewrite 27 as base 9? No. In this problem, we're going to have to rewrite both bases. What base are we actually going to have to pick? 3. So 9 has to be split again. So really 27 is going to be changed out to be, so 3 to the 3rd, but then that's raised to x plus 4. And 9 is really 3 squared, but then we have to remember there's the 2x. Now, before you drop your bases, shift your parentheses, right? Shift your parentheses up into that exponent. Base of 3, 2 times 2x. Base of 3, 3 times x plus 4. Bases are the same, so we drop them. 2 times 2x equals 3 times x plus 4. You guys solve for x on your own. Geez, this might have been the nicest answer we've had all day. Did you get 12? Okay, one more. What do you want your base to be on this? 4? 16? 4? How do you know?
Because you will have to divide it like 16 times 2 and go to 2.
Okay, so if you wanted to go with 16, Caden's absolutely right. If I take a 16 out of 32, what do I get? 16 times 2. Well, I can't read, I don't have the same base. Guess what base I'm going all the way down to? 2's. Okay? Work these all the way down to 2 and see what you can get. Use your factor tree to figure out how many 2's you have. See if you can solve this on your own. I'll give you a head start, and then I'll put your answer up. So much for nice answers, huh? I got negative 13/4. Anybody else? The easiest way to figure out your base is Up here with my factor trees, I know I needed to take 2's out. And then I got to just figure out how many 2's it took me to get there. What do you think your common bases are going to be today? Your prime numbers. 2, 3, 5, 7. That's probably about it. Okay. All right, stop and listen. Amber has never done Alex with us, and I will roll through Alex just to explain it to her. Okay? But let's talk about grading purposes. How does Ms. Hoff grade your homework? Based on completion. Okay? When we have book assignments, which it seems to be kind of far and few between anymore with book assignments, as long as you've made a solid effort. On Alex assignments, what do I expect you to get? 100%, which seems daunting at first, agreed? But what's the benefit of the way Ms. Hoff has it set up? It's unlimited tries. Last week you had a 19 and a 25, but usually you're under 20 problems, agreed? And what happens if you get it wrong? So say you did 1 through 5 and you got number 3 wrong. Do you have to do all of them again?
No, it's like screwed it up.
You only have to do the one you got wrong. Okay? Log in, get started. Don't let me hear your voices. There's scratch paper in the back. Okay.